Very good morning to all. We'll start today's class. So in the previous class, we started our discussion on latches and flip-flops, and we have discussed what exactly you mean by a sequential circuit, then how it is different than the combinational circuit, and we have studied one basic latch called SR latch or the RS latch, and we have seen how SR latch work. We have seen the construction of SR latch using two cross-coupled NOR gates, and we have seen that in the SR latch, when both the inputs S and R are 0, 0, there will not be any change in the output, means the latch remains in the previous state. When S is equal to 0 and R equal to 1, it resets the latch. That means the Q output will be 0. When S is equal to 1, R equal to 0, it sets the latch, which means Q equal to 1 and Q bar will be 0. And when both R and S inputs of SR latch are 1, 1, we have seen that that particular input combination is called as forbidden or illegal combination, because when both the inputs are 1, 1, both outputs of the flip-flop will give the same output, which violates the basic definition of the latch or a flip-flop. Hence, that condition is called as the forbidden condition or the illegal condition of the SR latch. Right? So I hope all of you understood what exactly the SR latch is. We'll proceed further. If you understand SR latch thoroughly, then definitely you can construct all other latches or flip-flops very easily without any trouble. Right. So we'll proceed further. Right. We'll see the one simple application of the SR latch, because already we have seen how SR latch functions. Now in this case, we'll see how the SR latch can be used for switch debouncing, because this is the major problem we face when we use especially mechanical keys. So what exactly you mean by switch debouncing? Or many a time they will ask the question, explain the working of SR latch and show how SR latch can be used in switch debouncing. In fact, this is a very important question. Maybe you can expect this for your second ADE test, which will be scheduled from 10, 11 and 12th of December. Your second CIE test in descriptive mode will be there from 10th, 11th and 12th of December. Right? Anyhow, today you may get the timetable from your department regarding the same. Right. So how this SR latch can be used for switch debouncing or key debouncing, we are going to study here. So before we see how SR latch can be used for debouncing purpose, you should know what exactly you mean by this switch debouncing. Right. So when you use a mechanical switch, whenever a switch or a mechanical key when we use, when you press that particular switch or when you try to close that switch, it, because of the mechanical element involved there, that particular switch contacts tend to vibrate or bounce, open and close several times before it is settling down to its final position. So normally when if you use, like you consider the keys available in the keyboard, if you press any key, and if you assume that all these keys are mechanical keys, then what happens if I have pressed the key P, it may happen that that particular key, before it settles down to its final value, since we have used the mechanical key, there will be several opening and closing of this particular key, and this problem itself is called as the key debouncing or the switch debounce problem. I hope it is clear what exactly you mean by switch debouncing. When you use mechanical switch and when you try to operate that particular switch, before it assumes its final position, there may be several opening and closing of that particular switch. And this problem itself is called as debounce problem in the switches or the keys. And this debounce will produce a noisy transition, and this noise can interfere with the proper operation of the circuit. That means actually when I press that particular key, it should assume that particular value, the final position value. But before it assumes the final value, there will be several opening and closing, and that creates the noisy transition, and you may get the improper operation of the logic circuit. So to overcome this switch debounce problem, how we can use the SR latch? That is what is shown here in this particular slide. So if you see here, what I have shown is simple SR latch is shown, right? You can see two cross-coupled NOR gates are shown. And again, don't get confused. Actually, here I have shown R down, but it is, you can see output of the NOR gate where R input you have given, I have denoted by Q only, right? So don't get confused with this diagram and the previous diagram, what you have seen. So how this particular circuit can overcome the debounce problem, that's what we need to study, right? See, these people, they don't join on time, they disturb everybody. Sejal, from next time onwards you should join on time, okay?
Yes, sir. I'm sorry, sir.
Okay, switch debouncing with SR latch, that's what we are discussing here. Now you can see what arrangement we have shown is, we have used one mechanical switch here. The mechanical switch can be either connected to +5 volt or 0 volt. That means it will be connected to either logic 1 or logic 0. And here I have used, we have used two pull down resistors. That means under normal operating condition, both the inputs S and R will be pulled down to 0. That's why those resistors are called as pull down resistors. So these pull down resistors ensures that contacts A and B are connected to ground or both will be 0. And you know that when both the inputs of the SR latch are 0, 0, what will be the output of the SR latch? Yes. When S is 0 and R is 0, what will be the output of the SR latch? The output of the SR latch will not change. It remains in the previous state. That's why the condition is called as no change state. So these pull down resistors ensures that the both inputs are connected to what? Both these inputs, that is input A and B, are connected to ground. So in the absence of any input, S will be connected to 0, R will also be connected to 0, and whatever is the output of this latch, the latch will remain in the same state. Now we are using here a mechanical switch. You can see this is the mechanical switch, right? So this switch can be thrown either to position A or to the position B. When the switch is connected to position A, then the input R becomes 1, and when this switch is connected to position B, in that case the input S will become 1. Now we have shown that here switch is connected to what? The position 2 or position A, and hence R will become 1. So S is 0, and now we have considered R equal to 1, because you can see here the switch is connected to R. So what happens now when R is 1? Though you are connecting that particular switch, that is you are making R equal to, initially I am assuming that R is 1. Now when R is 1 and S is 0, for this period I get the output as what? 0, because R equal to 1 resets the flip-flop. So you will get Q equal to 0. When R is 1, you are going to get Q equal to 0. Now, if before this particular switch settle downs, right? If I want to remove this particular switch contact from A, then what happens is, before it assumes its final value, there will be several opening and closing. Those opening and closing are shown here. That means R becomes 0, or it becomes 1, or 0, 1. There will be several opening and closing. This is called as debounce of that particular switch or the key. And because of this debounce of this key, there should not be any change in the output. Though there is a debounce of the key, the output should remain same. The output should not change. So to ensure that, we are using this what is called as SR latch. Now we have to explain how SR latch will take care of this key debounce problem Even though there is a several opening and closing of that particular switch, there will not be any effect in the output of that particular latch. That is what is shown here. So the timing diagram shows what happens when the switch is flipped from A to B. So we are assuming the switch is at A, and when the switch is at A, as I said, Q will be 0. Now we, at this instant, we are releasing this key, right? We are moving the key from A to B. When the switch is moved from A to B, what happens? As the switch leaves A, it will not immediately go to B and settle down to 1. There will be several opening and closing. When the switch reaches B, there will be several bounces that occur at the yes input, right? So this part I have explained you now. Now I am telling what happens when the switch is moved from A to B. So when you move the switch from A to B, actually what should happen? Yes should immediately become 1, because you are connecting the switch to B position. But since it is a mechanical key, there will be what? Several opening and closing of the switch at B, and that is what is called as switch debounce. So yes will become 1, again it becomes 0, 1, and then finally it settles down to 1, because we are connecting this switch to B. So this is called as the bounce interval. During this bounce interval, now what happens, right? So whenever a switch is 1, whenever the S becomes 1, the moment S becomes 1 and the R is 0, so what will be the output of the latch? Q becomes 1, right? R is already 0, R is 0, and momentarily you are making S equal to 1. So R equal to 0, S equal to 1, sets the latch, you will get Q output equal to 1. But now, momentarily, this S will go to 0 because of the key debounce. If it goes to 0, what happens? What are the inputs you apply to the latch now? What are the inputs applied to the latch for this interval? Because momentarily S has become 0. R is already 0, S has become 0. Now both the inputs are what? 0, 0. And when both the inputs of the latch are 0, 0, what will be the output of the latch? What will be the output of the latch?
0, 0 or 1. 0.
No, when both the inputs are 0, 0, the output of the latch will be the previous
No
output.
change.
Previous output. What is the previous output? Previously what you have got here, you can see. Previous output is 1.
1.
So the latch remains in 1. Now again, if it goes to 1 or 0, that means even if there are several opening and closing at the switch position 2, these several opening and closing will not have any effect on the output of the latch, and the output of the latch remains 1. So this is how we are overcoming that key debounce problem by using SR latch. So normally what happens is, whenever you move the switch from A to B, there will be several opening and closing at B. These several opening and closing at B makes the S input 1 and 0 several times. Momentarily it becomes 1, then it becomes 0, then again it becomes 1, then becomes 0, and then maybe it is settling down to 1. So even if there are several changes, switches, transitions occurring at that particular instance, what happens is, the moment S input becomes 1, Q will be 1, and subsequently when S becomes 0, Q will not become 0, Q remains 1, because when S becomes 0, the latch enters into the no change state and it will hold the previous value, and that is the important property of the SR latch, which is used in key debounce problem. So I hope it is clear how the key debounce problem is overcome. Key debounce means what? Whenever you are connecting key to a particular input of the latch, there will be several transitions. Even though there are several transitions, the output of the latch will not change. It will assume the final value, and that itself is called as the switch debouncing problem solving using SR latch. The same thing happens when there are several transition at R or several transition at S. Like if you assume here the first case, when the switch is connected to R, it will become 1. When R is 1 and S is 0, so Q output will become 0. Now, even if R becomes 0 again, both will become 0 and the latch enters into no change state and Q will remain as 0. So, when these transition occurs at R, when the transition occurs at R, Q output remains 0. There will not be any change in the output because of the reset and no change state. Similarly, when these transition occurs, the output will remain 1 because of the set state and the no change state. So that no change state of the SR latch will come into picture and it will retain the first value or the previous value, and there will not be any change in the output of the latch. So definitely we can solve the problem of key debouncing or switch debouncing using SR latch. So any doubts here? All of you understood this? How a SR latch can be used for switch debouncing. So basically debouncing means there will be multiple opening and closing or multiple on and off, or the value will change from 0 and 1 several times before it assumes its final value. So when the value of a particular input is changing several times before it assumes its final value, the output of the latch should not change, and that will not change because the latch enters into the no change condition and it retains the value which is supposed to retain. And that is called as the switch debouncing problem of the SR latch, or solving the switch debouncing problem using SR latch. So any doubts here? All of you understood? Yes? If you are not understood, you can ask. I'll explain that part once again. It is simple. I have explained you what exactly you mean by switch debouncing. So if you don't use this SR latch, assume that you are not using this SR latch, and if this switch, if you are directly connecting to some part of the circuit, then what happens there, that input will change many times. Accordingly, the output of the circuit also will change. So to overcome this, what you have to do is, in between that circuit where you are connecting this switch, you have to introduce this latch. If you put the latch in between the switch and the outputs, inputs of the circuit, then definitely a stable input will be provided to that particular circuit through the SR latch. So here SR latch is acting like a mediator, so that it will take care that even though there are multiple variations in the input because of the mechanical switches, that will not have any effect on the input of the actual logic circuit, and that problem we call it as switch debounce problem. Is that clear? All of you understood? And I say at least yes or no, man. Yes, how many of you understood this? Yes? How many of you understood? When I ask how many of you understood, there are no responses at all. That means how active you people are, I don't know. Yes? Yes, Namita, you understood?
Yes, sir.
Can you explain what exactly you mean by switch debouncing and how it is overcome using SR latch? Yes, in brief, in your own words, can you explain what do you mean by key debouncing or switch debouncing problem and how it can be overcome using SR latch? That is a simple concept I explained, but it is a very important concept. Yes, can you explain? See, left the meeting. Very good. Right? Can anybody try? Aniket?
Yes, sir.
Yes. First, explain me what is switch debouncing problem. Then Aditi will explain how it is overcome using SR latch.
So whenever we try to change the key from one point to another point, there occur some openings in the switch.
Okay, there will be multiple contact. There will be a contact and no contact. Basically, mechanical switch, how it works? There is a contact, means you can consider it as a close. If there is no contact, you can consider it as a open. It is like 0 and 1, or open and close. Right? Yeah.
Yes, sir.
Yes, continue. That problem itself is called as, in fact, a key debouncing problem. Yes. Now, how it is overcome, Aditi? Yes.
So when we insert the NOR,
Yes. Because this is very important concept used in digital circuits or the sequential circuit, key debouncing. Okay, one more, Aditi. Yes.
Yes, sir.
Yeah. What is how this key debouncing problem is overcome using SR latch? You're not understood?
No, sir.
Then when I ask whether you understood, if there are any difficulties, there is no answer from your end. Yes. That shows like how involved you are in the class. Okay. Anybody? Nikhil? See, you people are not at all interested, I guess, in classes. And again, I'm repeating, there will be an exam conducted. Like, don't be under the impression that this time also there will not be any exam. But obviously, third semester exam will be a bit late. First, seventh semester exams will be conducted, then fifth semester exams will be conducted, and lastly, third semester examinations will be conducted, because lateral entry student has to join. So your exam may be in the month of March, as per the yesterday's like information. First in the February, first or second February second week, there may be seventh semester examination conducted. Then February last week, fifth semester, and March first or second week, third semester examinations will be conducted. So I am telling this that there will be examination as per the same regulation. There will not be any change. So you become bit serious and try to study all the subjects. Yes, can anybody tell me how SR latch eliminates debounce problem? Yes, anybody voluntarily? You give a try. See, nobody will come voluntarily. Yes. Yes, Richa. Okay, Omkar. There is no response from anybody. Omkar, are you there?
Yes, sir.
Can you explain how SR latch overcomes key debounce problem? Okay, it is there on the screen. With the help of this, can you explain? This is self-explanatory, in fact, how SR latch eliminates key debounce problem. You consider when you connect the switch to R position, R should assume the value 1 and we should get the output as 0, because R equal to 1 resets the latch, right? So whenever the 1 is given, there should not be any change in the output, that is R should remain to 0. Whether it remains 0, even if there is a multiple closing and opening of that particular switch at the position of R, that you have to explain. And second, same thing you have to explain when the switch is connected to position yes. And when the switch is connected to position yes, the output Q should become 1. Even if the switch closes or opens multiple times, Q should remain 1. How it remains at 0 when the switch is at position R, and how the output remains at 1 when the switch is at position yes. That's what you have to explain And that is how SR latch eliminates the switch debouncing problem. Right? Can you give a try, Omkar? Just whatever you understood. And I told it is a very important from your examination point of view. In fact, I have given you one question for your second CIE, right? Like the question could be, explain the working of SR latch and show how SR latch can be used for switch debouncing. Right. So all of you should be able to write the answer. As a homework today, you should try to write the answer for this particular question. So I want someone should add little bit value, whatever you understood, you try to explain. Sohan?
Yes, sir.
Yes, can you explain?
Yes, sir.
Yes, give a try.
So first of all, switch bouncing is the action of touching metal contacts physically,
Okay.
which work in a different manner. Like the metal contact bounce upon each other.
Okay. It is like a
And
spring action. You have seen the spring. When you press the spring, what happens? It will not remain there only. It will bounce back. No.
yes, sir.
Like same action is called as debouncing here actually. Because normally when you say mechanical switches, it is like a spring-like structure. Okay. Yes. Go ahead.
And we use SR latch to overcome this.
How it overcomes, that is my question. I have explained you with the help of this particular circuit diagram as well as the timing diagram, and why we have connected the pull down resistors also I have told you. So that in the absence of any input, if there is no switch connected to any of the position, both will remain 0, 0. And when both the inputs are 0, 0, you know that SR latch will not change its output, it will retain the previous value. That is what is called as no change state of the SR latch. Okay.
Okay. So I'm not sure if I can explain you exactly.
No, whatever you understood, that's what I am telling. Correct. How much you understood in your own words, you try to explain.
First, the timing diagram shows what happens.
Okay.
Which leaves the bounces. So I guess like whenever we give the input voltage to A or B, the opposite NOR gates change their values to give the desired output.
No, for that a simple thing. Yesterday I understood the working of SR latch. In
Yes,
fact, I
sir.
have explained once again today. You have to remember in SR latch, when S is 0, R is 0, flip flop, that latch will remain in the previous state. Previously, if 0, the output remains 0. Previously, if it is 1, the output remains 1. Right?
Yes, sir.
When S is 0, R equal to 1, it resets the latch and the Q output will be 0. Similarly, when S1 and R0, it sets the latch so that Q output will be 1. And when both are 1, 1, it is forbidden or invalid. So for 0, 0, no change. 0, 1, it is reset. 1, 0, it is set. And 1, 1, forbidden. This is what you have to remember. That's
Yes,
what,
sir.
when S and R both are 0, 0, the latch will remain in the previous state. Whatever is the previous value, it will retain that. Okay. So anybody can give a try, or else I'll explain once again. All of you
Yes, sir. Explain it
just
once again,
have
sir.
attention. Okay. Okay. So here, what is this portion? What is this? Only this portion. If you see, what is called as?
SR latch.
This is SR latch. Very good. Which is constructed using two cross-coupled NOR gates. Now, in addition to this SR latch, we have added this circuit. This is called as switch debouncing circuit that is added along with the SR latch. Now, what for? I'll explain one by one. This first part is SR latch. Already you know the working of that. Now, I have added two registers. This is register 1 and register 2. And these two registers are connected from S input to ground and R input to ground. So, in the absence of this part, what happens? In the absence of this part, these two registers ensures that both S as well as R are connected to what? What it ensures? These resistors will ensure that both S and R are connected to what? Both S is connected to ground and R is connected to ground. That means both will be 0. S is 0, R is 0. And when both S and R are 0, 0, what happens? When both S and R are 0, 0, what happens? Yes?
Q
The
becomes
latch
1.
will remain in the previous state. There will not be any change in the output of the latch. Okay. So I have explained what for these resistors are used. And now here, what is this? This is what? A mechanical switch. Two position or two-way switch, you can say. It can be thrown to position A or to position B. This is a two-way mechanical switch. When the switch is at position A, like logic 1 will be connected to R, and when the switch is at position B, logic 1 will be connected to S. I hope all this is clear. Right. Now, assume that initially S is 0 and R is 1. So what output you are going to get till this position? What will be the output? Yes, S is 0, R is equal to 1. So in the SR latch, when S 0, R 1, R equal
Reset.
to 1, resets the latch and you will get what? 0 output. Okay. This is the 0 output you have. Assume that initially. Now at this position, we are changing or we are connecting the switch to what position? What position? A. At this instant, we are connecting switch to the position A. So when you connect the switch to the position A, what happens? When the switch is connected to position A, there will be multiple opening and closing of that particular switch. Right, these are, you can see here, multiple closing and opening are shown here, and that is called as the bounce interval for the what? Switch bounce at the position A. Similarly, here S is 0, and at this interval, what we are doing is, yes, that switch is thrown to position B. When the switch is thrown to position B, what happens? There will be multiple opening and closing at the position B, and the value of S will not become immediately 1. It will become what? 1 or 0. Right. Now at this interval, we are throwing the switch from A to B. When we are throwing the switch from A to B, what happens is, the moment a switch is connected to B, what will be the value of S you are going to get? The S will become 1. Immediately at this instant, you can see S will be thrown to B. So B will become 1 and S will become 1. And the moment S become 1, you will get Q equal to what? 1. Because this is 0 now. We are ensured R is 0. And here S has changed to 1. But what is happening is S is not remaining 1 throughout. S has become 1, so it has given output 1. But now what happens, because of the switch debounce, S becomes 0. Now what are the inputs given at this interval? S is 0, R is also 0. So what happens? What will be the output of this circuit then? What will be the output of the switch when both are 0, 0? When both are 0, 0, there will not be any change in the output. So output initially we have 1, it remains in 1. Then again S becomes 1 here for this interval. When again S becomes 1, it sets the latch irrespective of the previous value. Previous value may be anything. The moment S becomes 1, Q becomes 1, so Q remains 1. But again when S goes to 0, right, both become 0 and it will not change the output of the circuit because it is a no change state. Previous value is 1, so it remains 1. So in this way, what we are doing is, though there are several opening and closing at the switch S, those will be opening and closing will not have any effect on the output of the circuit. The output should remain to what? 1. It remains at 1. So this during this bounce interval of the switch, there will not be any change in the output. So this is how we are overcoming what? The problem of switch debouncing using SR latch. Same thing happens here also. Suppose if R has to change from 1 to 0. Initially it was 1. Now you are removing this. The moment you relieve it, immediately it will not become 0. Because we assume initially R is 1, and at this instance we are releasing that switch from the position A. Here we are putting to position B, like we are putting it at position B, and here we are releasing from position A. I hope it is clear. When the switch is released from position A, R should become 0 immediately. But it will not become 0 immediately. It will take several transitions, several opening and closing. And because of this several opening and closing, the output will normally change if you connect that directly to some part of the circuit. But in between, we are using this SR latch. So this SR latch will take care of keeping the output constant to 0, and the output remains 0 even though there are several opening and closing. So in both the cases, right, the output whatever we supposed to get, we are getting the same output, like 0 here and here 1. Hence there will not be any change in the output of the circuit when we introduce the SR latch. And this is how the SR latch eliminates what? The switch debounce problem. I hope clear now at least. Sohan?
Yes, sir.
Omkar, is it clear?
Yes. Yes, sir. Clear.
Okay. We'll go ahead now. Quickly, I will explain you SR latch using cross-coupled NAND gates. Again, I have used the similar structure like how we are using cross-coupled NOR gates. Now we are using a NAND gate. Right? This is NAND gate 1, NAND gate 2. But instead of giving the inputs as R and S, I have shown the input here is S bar, input here is R. That means actually if you have a S will be complemented and it is given here. So this is yes. R also will be complemented and given here. So now why we are giving it in complemented form is to have the same function table or the truth table of the SR latch, like our SR latch using NOR gate. So this is the block diagram of this SR latch. So inverted inputs we have given S and R. So now what happened? If we give S bar and R bar as 1, 1, that means S equal to 0 and R equal to 0. This is the first input combination. If you give, definitely S bar and R bar becomes what? 1, 1. 0, 0 we have given, but it is complemented, both are 1, 1. And we know that the property of the NAND gate, if you see, output of the NAND gate will be 0 only when both the inputs are 1. Even if one of the input to the output of the NAND gate is what? 0. Output of the NAND gate is 1 when one of the input is 0. Right? But when both the inputs are 1, 1, in that case the output will be 0. Right? So now if I give S equal to 0, R equal to 0, S bar and R bar are 1, 1. The moment you see 1 as an input to the NAND gate, we will not able to decide its output unless and until we know the other input. The moment you see 0 as the input, you can give the output. But when you see 1 as the input, we will not be knowing what is its output. So initially, if I assume Q equal to 0 and Q bar equal to 1, now this 0 will come here and this will produce the output as 1. And this one along with this one, it produces 0. That means when we give S equal to 0, R equal to 0, means S bar equal to 1, R bar equal to 1. If initially Q is 0, we are getting Q equal to 1. Similarly, it can be shown that if Q is 1, you are going to get 1. So this state is also called as what? The no change state. That is when S S bar equal to 1 and R bar equal to 1, or in turn S equal to 0, R equal to 0. Now for this case, you can see for both these cases, when S bar is 1, that means S is 0, R is 1. If you give S0, R1, this is 1 and this will be 0. Now what happens in this case? The moment you see 0 here, the moment you see 0 here, what happens? This output will become, what it becomes? This output becomes 1. 0 at the input of the NAND gate forces the output to 1, and this one will give the output as 0. That means irrespective of previous value. For this case, we are not checking what is the previous value. Irrespective of the previous value, when you give S bar equal to 1, R bar equal to 0, we are going to get 0 as the output, and this is called as a reset state. Right? And then if you give S equal to 1, R equal to 0. S equal to 1, R equal to 0 makes what? This will become 1 and this becomes 0 now. 0 will force the output to 1. This one along with 1 will give the output to 0. That means the moment you give S equal to 1, R equal to 0, irrespective of what is the previous value, you are going to get the output as what? In both the cases, you will be getting output as 1, and this is called as the set state of the latch. And now if I give both as 1, 1, that is R1, S1, so both will become 0 now. When both become 0, both the outputs of the NAND gate becomes 1, which violates the basic definition of a latch. Hence, this is called as forbidden or invalid. Again, in this case also, we got the same truth table, that is when S0, R0, no change, when S0, R1, reset, when S1, R0, set, and when both are 1, 1, that is called as forbidden state. So the same truth table we are getting for SR latch using what is called as a NAND gate. But only thing, here we have to give the inputs in complemented form, that is S bar and R bar. Why we are giving in complemented form? To retain the same truth table. To retain the same truth table, we give. If you don't give it in complement, if you write this as S and R, maybe that set and reset and no change and the forbidden state will be exchanged. So to avoid that, we have given the inputs in complemented form so that we can have the same truth table. So after knowing SR latch using NOR gate and NAND gate, now we should be able to have what is called as a gated SR latch. Now there is no change in the previous circuit and this. This is the circuit what we have. Right. This is the circuit of the SR latch using NAND gate we have. The same I have connected here, but instead of showing the inverter, I have added one signal now, gated signal. So if G is 1, whatever value of SU gives here, you will get S bar here. And if G is 1, whatever value you give, you get R bar here. That means we are generating S bar and R bar from S and R only when this gated signal or the enable signal is 1, and this latch is called as gated SR latch. So this will work only when G is 1. When G is 1, S is 0, R is 0, you will get no change. You can try to analyze that. When G 1 and when S is 1, R is 0, you will get set. When G1, S0, R1, reset. And when G is 1 and both S and R are 1, 1, are forbidden. But when G is 0, the moment you give G is equal to 0, here you are going to get what? What will be the output of this? 1 and 1. Right? So the moment if G is 0, this gated structure will not come into picture and it will remain in the no change state. Sorry, when G is 0, this becomes 0, 0, so that it will remain in the no change state. So this is called as the gated latch. And that race around condition is, as I explained, when both are 1, 1. That is, when S is 1 and R is 1, both outputs will try to become 1, which violates the basic definition of the latch, and that itself is called as the race around condition in the latches or the race around condition in the flip-flop. Right? So that is about the SR latch. In the next class, we will study about D latch, JK latch, or just D latch, how a D latch can be constructed from the SR latch. Then we will study SR flip-flop, how SR flip-flop can be modified to JK flip-flop and D flip-flop and T flip-flop. After studying all the 4 flip-flops, we will see how we can derive the next state equation of the flip-flops, and those are called as the characteristic equation of the flip-flop. So that is a very important part of this part. And once we know all the 4 flip-flops, in the last part of this module, we'll see how these flip-flops can be used to construct what are called as the counters. Right? So with this, we'll close the today's class. If you have any doubts, you can ask me. If anybody is having any doubts, you can ask the doubts, or else we will end the today's class.
Hello, excuse me, sir.
Yes?
So you mentioned the gate, right?
What?
Gate latches.
D latch.
Gate latches. Gate latches.
Gated latch. Gated means what is? There we are using one enable signal. When that enable is high, then only your inputs will come into picture, and based on the values of S and R, it will be either set, reset, no change.
So why can't we use a clock there?
That's what I am talking only about the latches now. What is the difference between latch and a flip-flop?
Latches will not be it will
Having
be
any clock. Clear? So I have told it as gated latch. I have not called it as a flip-flop. If you replace that gated signal or enable signal by a clock, then it becomes SR flip-flop. I'll come to it in the later stage. Because right now I am teaching you only latches. I have not yet talked about the flip-flop. When the clock comes into picture, your latch will become what? Flip-flop. That is the next part which we have to study. I hope your doubt is clear, Sana?
yes, sir. Yes, sir.
Yeah. Because I am talking only about latches now. Once you are clear with the latch, then we'll see how we can construct the flip-flop and the other like the flip-flops. Is that clear?
Yes, sir.
A very good doubt. Any other doubt if you have? Yes.